Okay, in this video I'm going to go through a few functions questions. These questions are after coming from the Junior Cert higher level, but they'd be suited to Leaving Cert ordinary level as well. Right, so first question. The solutions of the equation x squared minus x minus 2 equals 0 are x equals minus 1 and x equals 2. So they're the roots. So this is where the graph or the function crosses the x-axis. The table below shows three graphs. One of these is the graph of the function above. Put a tick in the correct box to show which of these graphs is fx equals x squared minus x minus 2. Okay, well, first of all, we know that where the function crosses the x-axis is at minus 1 and 2. So let's see, this crosses at minus 1 and 2, so it could be that. This crosses at minus 1, so it could be that. And this crosses at minus 2, 1, so it's not that. And now I'm going to look for where it crosses the y-axis. So this crosses the y-axis at minus 2. So that means if I put in 0 for x in this equation, it should give me out minus 2 if this is the graph. Okay, this one here crosses at minus 3. So if I put 0 into this equation and it gives me out minus 3, it's going to be this one. If it gives me out minus 2, it's going to be this one. Okay, so let's see. We have f of 0, because we're putting in 0, equals 0 squared minus 0 minus 2. Which is f of 0 equals minus 2. Minus 2, so it must be A. Next question then, they're asking us to draw three graphs. Okay. So we're going to graph this function first. So y equals x minus 1. Now I know from that it's linear because there's no squared or cubes up here, so it's going to be a line. So I just have to plot 2 points and draw the line. So I put in minus 2 first. So minus 2 minus 1 is minus 3. So when I put in minus 2, I got minus 3. So minus 2 minus 3. Here we go. And the next one, should I put in 2? So 2 minus 1 is 1. So when I put in 2, I got 1. Here we go. So there's our function. Second one. Now I am going to have to plot all the points. And remember, the domain goes from minus 2 to 2. Okay. So we'll do the minus 2 first. Right, so y equals 2 minus x squared, and I'm going to put in minus 2 for the x squared in brackets. So 2 minus, and then minus 2 squared is 4, so that's minus 2. So when I put in minus 2, I got minus 2. So minus 2 minus 2. So there we go. Next one, put in minus 1. So it'll be 2 minus, and minus 1 squared is 1. So that is 1. So I put in minus 1 and I got 1. Next one, put in 0. So 2 minus 0 is 2. So I got out 2 when I put in 0. So 0, 2. Next I put in 1. So it's 2 minus 1 squared is 1. So that's giving me out 1 when I put in 1. So 1, 1. Which is here. And the last one, I put in 2. 2 minus and 2 squared is 4. That gives me minus 2. So when I put in 2, I got out minus 2. There we go. And there's our graph. And that makes sense because look, it's a squared, so it should be an n or a u, and it's a minus x, so it's going to be an n. This one is going to be exponential. So here we go. To x, and I'm going to put in minus 2 for x, and that will give me a quarter. So when I put in minus 2, I got a quarter. So minus 2 a quarter, which is about here. Next I'll put in minus 1. And I'll get a half. So when I put in minus 1, I got a half. So minus 1 half. Next I'll put in 0, and anything to the power of 0 is 1. So I put in 0 and I got 1. Then I put in 1. 2 to the power of 1 is 2. So when I put in 1 I got 2. And lastly then I put in 2, and 2 to the power of 2 is 4. So when I put in 2 I got 4. And we know that that's the shape of an exponential graph. Okay, and if it kept going, it would keep going up and up and up like that. Next question. A school can get its electricity from one of two companies, Bose or Lecky. The graph shows the cost of the electricity per month for each company. If the school uses X units of electricity, so however many units of electricity, the cost from Bose is BX and the cost from Lecky is LX. So here's Lecky. And here's Bose. One of the companies charges a fixed fee each month, plus a fee for each unit of electricity used. State which company charges no fixed fee. Well, over here is the cost per month, and over here is the units used. So a fixed fee would be you have to pay it at the every month, regardless of how much you use. So if you use 0 amount units of electricity, you still have to pay the fee. Whereas the company that charges no fixed fee, well, if you don't use any units, you don't pay anything. So let's see. If we use 0 units here with Lecky, well, we still have to pay 50 euros. If we do 0 with Bose, we actually have to pay nothing. So the answer is Bose charges no fixed fee. And why? Well, because if we use 0 units, we pay nothing. Right? Write down the domain and the range of the function of bx. Bx is Bose. Well, the domain is the numbers we put in, the x numbers. The range is the numbers we get out. So the domain goes from 0 to 1000. So 0 to 1000. But we can write that in a more mathematical way. So we can say x is greater or equal to 0 and less than or equal to 1000. Okay. And then to find the range, well, the range is going from, we're looking at the y values it gives out, and it's going from 50 all the way up to 325. So 50 to 325. Okay. Next question. Use the graph to estimate the set of values for which bx, which is Bose, is less than Lecky. So where is Bose less than Lecky? Let's see. Bose is the straight graph, and Lecky is the curved one. So Bose is, well, it's higher than Lecky here, but it's less than Lecky in this bit here. It's underneath Lecky here, so it is less than it from here to here, and then it goes, more than it again. So we can say between, what is it? We'd always read from the x-axis, so it's between 100 and 800. So between 100 and 800. Okay, the way I would write that mathematically is like that. Okay, when x is greater than 100 but less than 800. Next one, explain what your answer to part C1 means about the cost of electricity from BUZZ. Okay. Well, if we look here, if you're using between 100 and 800 units of electricity, well then BUZZ is cheaper. So if we use between 100 and 800 units of electricity, then BUZZ is cheaper. Find the slope of the graph BX. Okay, I'll just tidy this up a bit. BX is a straight line. We can choose rise over run, or you could use your slope formula. I think why not? We'll use our slope formula. Okay, so our 2 points. This one here is 0, 50, and this one here then is 1,325. Okay, so we write those down. 0, 50, 1,325. Okay. We could do the rise over run as well. Y2 minus y1 over x2 minus x1. Okay, that's the slope, and M stands for the slope. We put in, well, we label our points, x1, y1, x2, y2. We throw it into the formula, and we will get 325 minus 50 all over 1,000 minus 0. We'll get 1,000 on the bottom as the denominator. We'll get 275 on the top. Our answer then will be 0.275, and that's the slope. And the last part of this, explain what your answer to part D1 means about the cost of electricity from BUZZ. And what that means is the cost of electricity from BUZZ rises by 0.275 euros per every 1 unit used. Okay. And that's it, guys. Thanks.
Right. So in this video I'm just going to do a few questions. A lot of them taken from past exam papers. Some of them higher level junior cert, more of them ordinary level leaving, some of them ordinary level junior cert. So this question, it's a junior cert higher level, and it says the 3 curves A, B and C are shown in the coordinate diagrams below. 2 of the curves show a function of x, the other curve is not a function though. Put a tick in the correct box to show which curve is not a function. Okay. Now remember we said in a function that if we put in a number into the function, as in we put in one domain number, it can only give us out one number in the range. So for example, if we drew it like this, let's say 2, 3, and this was 4, 5. Well, that would be a function if I put in 2 and I got out 4, and I put in 3 and I got 5. But if I put in 2 and I got 4, and I put in 2 and I got 5 as well, that can't be a function. So let's see if any of these graphs, if I put in one x number, do I get back out 2 y numbers? Well, in this one, if I put in an x number here, I get 1 y number, 1 y number, 1 y number. Okay, so it's only crossing the graph, I was only crossing the curve in one place. So that's definitely a function. And this one, if I put in x numbers, say -1 and 0, I'm actually only getting 1. Here again, it's only crossing the graph in one place. 1. Okay. So no matter what x number I put in, it's still only crossing the graph in one place. So b is a function. What about c? Well, if I put this point into the graph, it'll cross it once, once. Okay, so far. Now it crosses here. So if I put in this value into my function, I get out this value for y, whatever that would be here. Look at this, it crosses it again. And if I put in this value, it hits it once, twice, 3 times. That can't be a function. Okay, so c is not a function. Okay, next question is out of the book. So a liquid is poured at a constant rate into these 5 containers. The height, HCM, of liquid in the containers is plotted against time in seconds. Match these containers with their graphs. Okay, well, the steeper the curve on these, that means the faster they're filling up. Okay, so if we look at, let's say this one. Well, that should fill fast and then start filling slower. So if it fills fast, well, then it should be steep and then not so steep. So if we look for one that's steep and then not so steep, this one looks pretty steep here and then not so steep at the end. So that'll be A. B then, well, B will fill slowly enough, then in the middle it'll fill a bit faster and then slowly again. So it'll be flat enough, then it'll get steep and then it'll get flat again. So if we look for one that's flat-ish, then steep and then flat, this one, so that'll be B. If we look then at, let's say, D, well, D is just going to be a constant. It's not going to go any faster or slower how it fills up. Right? So we're just looking for a straight line there, a constant rate of fill. So it's going to be this one. And the last one then. So if we look at C then, C is going to be relatively flat because it's going to be filling very slow. And then gradually it's going to get quicker and quicker, and then it's going to get very quick. Okay, so if we look at this one, it starts off very slowly filling. Okay, it's a flat enough surface, but it's getting steeper and steeper, and then it's shooting up. So this will be C. And the last one then, well, it's going to fill very quick down here, and then it's going to get slower once it gets to here. So look, very quick, then slower. Sorry, not this one. What was that? This one, very quick. Then it's getting slower on the middle. Then it's getting quicker, and then it's shooting up because it's going to fill really quick here. Okay. Okay. So in this question, we have a graph showing the journey of 2 motorists, Darren and David, and it gives their distances from their hometown. So on the y-axis we have the distance they are from their hometown, and on the x-axis we have the time. So for instance, at 11, which is here, well, if we go up here, David is 75 kilometers from his hometown, and Darren is, it's about 97 kilometers from his. Okay, so that's how we work this graph to answer the questions. Right, so the first question. How far is David from the town when Darren starts his journey? Well, Darren starts his journey at 10 o'clock. So we'll go up there. We'll hit David's graph, and David at 10 o'clock is 75 kilometers from his hometown. At approximately what time do their paths cross? So we're looking for time, so we'll be reading off the x-axis. Well, they cross here and here. So time 10:45 and 12:15. At what time does David begin his return journey? Well, he's getting further away from his house from here. Takes a break for a while, and gets further away from his house. And at this point then he starts to get closer to his house. So at this point he starts his journey home, which is at 1:30 p.m. And these are early. How far is Darren from the town when David begins his journey home? When David begins at 1:30, how far is Darren from his town? Well, 1:30, go up to Darren's graph, go across, and he's 75 kilometres. And who returns to town first? Well, David returns at 3:30 and Darren returns at 3 o'clock. So Darren. And what time elapses before the other motorist arrives? Well, as we said, Darren returns at 3, David returns at 3:30, so 30 minutes elapse.